Hello everyone, welcome to another video of my channel. Today we'll be talking about a new problem named Valid Palindrome 4. Its lead code number is 2330. It's a medium categorized problem. So let's get started. Here what we can see is we'll be given a zero index string S consisting of only lowercase English letters. In one operation we can change any character of S to another character. Now we will have to return true if we can make S a palindrome after performing exactly one or two operations. That means if we can make the given string palindrome by changing exactly one or two characters, then we can return true, otherwise we return false. Here in this first example we can see that the string is ABCDBA. Here the output is true. Why? If we have a look at the strings from the start and end position, here at the very first there is A and the very last there is A. It matches. Then if you proceed further, there is B and there is also B. It also matches. And at the very last there is C and D which don't match. So what we can do in this one operation, we can change either C to D or D to C. So in here we only need one operation to make this whole string palindrome. So we return true. Same goes for this example 2, true. And now if we have a look at this example 3, let's start checking. A doesn't match with F, so here we need one operation. If we proceed further, B doesn't match with E, we need again one operation, so 1 plus 1 2. And the last, C and D are not equal, so here we need 3 operations to make this string palindrome, which is more than 2, so we return false. Now let's start how we can solve this problem. Yes, at first we'll be taking 2 pointers at the start and end of the string. Let's say the name of the variable is start and end. The initial value of start will be 0. That means the 0th index of the string, and the initial value of end will be the length minus 1 index. That means the very last index of the string. We'll start checking characters at those pointers. So in every step we'll check whether the characters in those 2 pointers or index are equal. If they are equal, then we simply increment the value of start and decrement the value of end, and again do keep checking until start is not greater than or equal to end. That means they both merge to the middle point. Now what if they are not equal? Then we will take a count variable which will be initialized as 0, and every time we see an anomaly, that means at a certain index the value of ith index character and jth index or start index character or end index characters are not equal, we increase or increment the value of the count variable by 1. And at last we compare the count value. Whenever we encounter that the value of count is greater than 2, we return false, otherwise at the very last we return true. Now let's try to simulate it in some examples. This is our first example. So our start pointer will be here at A and end pointer will be here. As we can see, both of them matches. Now if we increment start, it comes here, and decrement end, it comes here. They are also equal. In the next step, B and X, they are not equal, so we increment our count variable by 1. So initially it was 0, now the value of count is 1. Again, this A and A are equal, U and U are equal, and here our condition matches. That means our checking is done. So from this example, simulating this example, we can see that we can make this very string palindrome by using only one operation, which is less than 2. So we return true from this example. Now let's try to see another example. Let's start comparing B and T. They don't match, so the count variable becomes 1. E and S, they also don't match, so it becomes 2. Now we encounter X with E, they also don't match, and here at this point we get the value of this count variable becomes 3, which is greater than 2. So we don't need to go further, we at once return false. Now let's try to solve this problem in Leetcode. Here we are taking a count variable, our start pointer and end pointer. This is our loop condition. If characters at those index are not equal, we increment the value of count variable. If count's value is greater than 2, then we return false. And here we keep incrementing start pointer and decrementing end pointer. Now if our loop ends, then we are pretty much confirmed that the value of count is less than or equal to 2. So in this point we return true. Now let's try to submit it and see whether we are correct. So we got a success, and we have a pretty much good runtime, which is only 3 ms, and memory consumption is 8.1 MB. Now let's talk about the running time complexity of this approach. If we have a closer look at this approach, we can guarantee that this loop will run at most the whole length of the string. If we consider the length of the string as n, then we can say that the running time of this approach is big O of n, because if we have a palindrome string, then the loop will traverse at most. That means both of these start and end pointer will collide. Otherwise, if say there are more than 2 operations needed, it will break. If there are more operations than 2, we do not need to even encounter the whole string. Now if we talk about the space complexity, we can see that we are not using any external data structure, so we can say that our space complexity is constant. That means big O of 1. So that's all from today. I hope you guys have understood this interesting and straightforward problem and its solution approach. Thank you very much.